everyone, welcome back. If you're working with cells, you know how crucial subculturing is. It's a key process to ensure your cultures stay healthy and continue growing. In this video, we're going to break down the what, when, and how of subculturing so you can confidently handle this essential step. Let's dive in. First, let's start with the basics. What is subculturing? Simply put, subculturing involves transferring cells from one vessel to another. This process helps prevent overcrowding and ensures that the cells have enough space and nutrients to keep growing. Without regular subculturing, cells can become overconfluent, leading to stress, poor growth, or even cell death. When cells are in an optimal environment with plenty of space, they continue growing healthily and at a controlled rate. Subculturing ensures that your cells remain in this ideal state. Now that we know what subculturing is, let's talk about when to do it. The key indicators are fairly straightforward, and understanding them will help you maintain productive cultures. One of the main signs is confluency. When cells reach around 70 to 90% confluency, they're nearing the end of the log phase, where they've been actively growing. This is the ideal time to subculture because overcrowding can slow growth and lead to cell stress. Another indicator is a change in the medium color. As cells metabolize nutrients, the medium's pH can drop, turning it yellow. If you notice this, it's a sign that the cells need fresh medium and more space. Now that you know when to subculture, let's go over how to do it step by step so you can follow along and see exactly how to perform the procedure. First, check if the cells have settled at the bottom of the culture flask. If they have, gently rotate the flask to evenly distribute the cells throughout the medium. Next, take a small sample of the cell suspension and perform a cell count. This will help you calculate how much fresh medium you'll need for subculturing. Now, let's look at two methods for subculturing cells. Method 1. Direct medium addition and splitting. Add the appropriate amount of pre-warmed growth medium to the culture flask. The amount should be based on the total cell number. If you're splitting the culture into multiple flasks, divide the cells accordingly. Loosen the cap of the flask to allow for gas exchange, or use a vented cap. Place the flask back into the incubator for continued culture. Method 2. Centrifugation and medium exchange. Transfer the cell suspension into a 15 milliliters sterile centrifuge tube. Centrifuge at 1200 RPM for 3 minutes. After centrifugation, discard the supernatant and resuspend the cell pellet in an appropriate volume of pre-warmed complete growth medium. Based on your cell count, dilute the suspension and transfer the required volume into new culture vessels. Loosen the cap and return the culture to the incubator. For those of you working with adherent cells, there are a few additional steps in the subculturing process. These cells require detachment from the culture surface before they can be transferred. This usually involves using trypsin or another dissociation agent to gently detach the cells. Once detached, the cells are typically neutralized with serum-containing medium and resuspended before being split into new flasks. If you need a more detailed protocol or step-by-step video for adherent cell subculture, feel free to leave a comment or reach out to us. We'd be happy to share more resources and guide you through the process. That's a wrap on today's subculturing guide. We hope you found this helpful and are ready to implement these techniques in your own work. If you liked the video, don't forget to like, subscribe, and follow us for more content like this. Thanks for watching, and I'll see you next time.